No, thank you and good night.
Hello.
Doesn't even clean it.
You have to take it away. Today, I'm going to teach you about archetypal. Okay, we're going to do a quick little video about stereochemistry. And so, some molecules have right-handed and left-handed versions of them, right? And so they differ in their stereochemistry, their arrangement in three-dimensional space. And so I'm going to draw a couple molecules here and I'm going to draw the right-handed and left-handed version, and we'll see if we can distinguish between the two and name one of them as the right-handed and one as the left-handed version. So here we're going to have a chiral carbon, a carbon bound to 4 different things. Again, we use wedges to show bonds that are coming towards us and dashes to show bonds that are going away from us. So we'll have 2 very similar molecules, but they're just going to differ in how these 4 substituents are arranged in three-dimensional space. So let's put an alcohol group here, maybe we'll put a hydrogen here, a methyl group here, and a chlorine here. The 4 things have to be different in order to provide the asymmetry to have this right-handed and left-handed versions. If things are symmetrical, the right-handed and left-handed versions, the mirror images look identical. So let's switch a couple of these substituents. So we've got 2 different versions of this molecule. One's the right-handed and one's the left-handed. And in organic, we don't use right-handed and left-handed. We call things either the R version or the S version. I like to think of the R version as the right-handed version and the S version as the left-handed. S stands for sinistra, which is like sinister, like left-handed people are evil and from the devil. So we're going to rank our substituents around this chiral carbon as we know how to rank. So this will be rank number 1, 2, 3. Hydrogen is 4th. The same over here. And the rule to try to figure out which one's R and which one's S is you put the 4th substituent away from you, so on the opposite side of the molecule. Now, since this is a dashed line, it's already oriented like that, which is handy. So I'm looking at this molecule with the correct perspective because my 4th substituent, the lowest priority substituent, is on the opposite side of the molecule. And then I look and I sort of trace a line from 1st to 2nd to 3rd, and I see whether this was clockwise or counterclockwise. And from my perspective, with the 4th substituent facing away from me, this looks like a counterclockwise rotation. Counterclockwise is S. Here, again, I have the 4th substituent pointing away from me, so I've drawn this in a convenient way so that it's on the opposite side of the molecule. If I go from 1 to 2 to 3, it looks like a clockwise rotation, and so the clockwise is R. That's how we look at the right-handed and left-handed versions of the molecule and how we designate them as either the S version or the R version.